Hello, I'm Josephine and we're live at ICLR. Today I'm joined by Maxime, who's the head of post-training at Liquid AI. Maxime, I would love to know a bit what your research is about.
Yeah, sure. So at Liquid, what we do is small edge models. We focus on efficient models that can run on device. We can run them in cars, for example. We can run them on GPUs, and we have a lot of applications around like how to make these models faster and consume less memory while maintaining the same level of quality.
Nice. So on the research you did this year, the paper you published, what exact findings did you uncover?
So something that I find super interesting is how to train the small models compared to like the very large ones, because we have a lot of recipes that target mostly the big models. And what we're interested in at Liquid is how to treat the small models as first class citizens. So the idea is how can we adapt these recipes to make the small models as good as possible. And one thing that we focused on this year is doom looping. Doom looping happens when the model starts repeating the same sequence of letters or words over and over again. And to do that, we found a good recipe in multiple stages that reduces the proportion of doom loop from like 15% to 0.3%.
Oh, wow, nice. And so for the real world applications, like what does it mean and where are these models in production and where did that specific fix help?
Yeah. So we've been working with Shopify, for example, for a while. And with Shopify, it's an interesting use case because instead of deploying the models on device, what they do is deploying them in the cloud because they have so many requests that they need tiny models that are able to do big data processing. And recently, we also announced a partnership with Mercedes. And here we deploy the model directly inside of the car to do that language understanding, but also speech. This is an audio model and it's able to understand your intent based on what you said, based on the history of your conversation and translate it into actions. So this is a really cool application of on-device small models for real in the car.
Nice. So you mean that in the car, like the more I talk to it, the more it knows how I like to talk?
It can understand like the intent that you have
Okay.
and create a profile around you to understand like what you mean when you say I want more of this, for example.
Okay.
This is the kind of thing where you need intelligence. You cannot just rely on like traditional systems for audio. You need to have something like an LLM that is able to reason about it and understand based on the context you provide to the model.
And so where is this new data stored?
It's stored inside of the car.
Inside of the car.
Yeah.
Wow.
Yeah.
Nice. What are some like new applications and new fields of research you want to explore this year to make the models better?
Yeah, there's a lot of things that are super interesting around agentic reinforcement learning. I think this is really, really cool to see how we're going to bring the capabilities of really big models like Opus, for example, and distill them into tiny models that can run on a phone and have this model basically running your calendar, running your emails, running a lot of applications like this. And I think this is like an area of research that particularly excites me because right now, it's only cloud models that can do this, but I'm pretty sure that this year we're going to see very, very strong tiny models capable of doing most of these things.
Nice. And so that will be able to run on your phone and get to more privacy faster.
Exactly. And like fully offline, for example,
Yeah.
if you don't have connectivity, it's a big issue. Latency is also better because it runs directly on the phone. So yeah, there are a lot of reasons why you would prefer to have a local model instead of a cloud one.
Awesome. Well, thank you very much.
Thank you.